Hyundai 25L, the complaint is a hard start. So let's try to recreate it. So I'm just going to turn the key on and go to crank it. No start. However, what I noticed is when you just go to start the machine without that delay I just did, it'll start up just fine. So go back to turn the key switch on. So it's not a true hard start. What's actually happening is with the E-Controls fuel system, there is a power relay that will time out after a couple of seconds. But once a start request input is seen by the ECM, it will control the power relay, and you will get voltage to your cam and crank sensor, your ignition coil, your lock off. And as of right now, we are missing that 12 volts after the timeout. Okay, so I'm just back probed into the power feed for the cam sensor. It's spliced. It's the same circuit that the crank sensor will get 12 volts and your ignition coils will get 12 volts and your lock off. All those are tied together from the power relay. So I'm just going to turn the key on. You see I got 12. Power relay shuts off. Now if I crank it, since there's no power to the cam sensor, the crank sensor, the ignition coils, well, there's not going to be no cam or crank input, and we're not going to have any spark, and we're not going to have any fuel control. So the engine is just solely going to crank. Like so. However, if I just do a full cycle of the key switch without pausing, as you can see the engine will run just fine. So after confirming that that's what my actual issue is, that it's not a true hard start, that the power relay is failing to be controlled by the ECM when there is a start request after it times out. So I just did a real quick, easy, basic check, and I just put this thing in any particular direction, here forward. So in that instance, this engine should not crank. So since the starter engages when I'm in a direction, the neutral safety circuit is bypassed. So upon further inspection, I saw that a wire was run from the start side of the ignition switch directly to the S terminal. So, well, that explains why it'll start in a direction when it's not supposed to. Not necessarily doesn't explain why it doesn't start after the 2-second timeout. So when I go to the fuse box, I notice that the starter relay is missing. So when you turn the key to the on position, the coil side of the relay, one end goes to the ECM. The ECM provides a negative, and then the other side comes from the ignition switch when you're in the start position. Obviously, it'll go through your directional switch first so that you have your neutral safety circuit, but ultimately when you go to the start position, you'll get 12 volts on one of the coil sides of the relay, and since the other side has a negative, relay gets active, the switch closes, and now whatever's on terminal 30 is now on 87, and the starter should run. Also, when there's 12 volts going to the S terminal, that 12 volts temporarily goes to the ECM. That's how it knows that you're trying to start, and then hence controls your main power relay, sending power to your ignition coils, your cam and crank sensor, and your lock off. So now I just have the starter relay in its spot, and I'm leaving their repair in because the wire that's actually supposed to go to the S terminal was cut and taped up, and it's non-existent. So this wire is solely going to the S terminal, and so we're going to try to recreate it. I'm going to turn the key on. There's a timeout. So now when I go to crank, voltage comes back. Maintaining voltage obviously on my cam and crank sensor because the engine's still running. So admittedly, when I did the wiring repair to the EPR, I did fix other wires that were within the wiring loom. So, and then when I went to retest it, I just, starts up right away, runs good. Because with one of the power feeds missing to the EPR, this thing goes into a default, and it defaults rich, and it starts idling very erratic. You can smell propane coming out the exhaust. Very dangerous. So after that was repaired, I didn't realize that with the other wiring that I actually repaired the circuit that they tried to bypass. So what I'm going to have to do is I'm going to have to reopen the section where it goes down into the starter, find that wire. It's a white wire, and I'm going to solder a new wire onto the S terminal with the appropriate connector, and this thing should be good. So the starter wire that comes from the load side of the relay, it actually wasn't cut when, I don't know exactly what happened or why whatever was done, but this wire right here that comes from the starter relay that is supposed to go to the S terminal was going to, let's see if I get a good shot of it. It's kind of hard because it's underneath the intake manifold. It was going to this orange wire right here, and that is connected to the ignition condenser, which if I could try to zoom in to get the light in there. Right there, if you can see where the other end of that orange wire is, that's the condenser for the ignition coils. So that's to cushion the ignition system when there are voltage spikes and variances in current. So they had the starter S terminal wire going to that device, and then a wire was ran from the ignition switch, from the start side of the ignition switch to the S terminal. So now that I got everything hooked back up the way it's supposed to be, back probed into the cam sensor power supply, gonna key on. All right. Power relay is timed out. Gonna crank it. And there you go. The bell is loose. That's why it's not charging at full capacity. But this, it's a lesson in, if you're going to attempt to bypass circuits, you know exactly what you're going to bypass. And the dangers, especially if you don't know exactly how the circuit is supposed to work. The dangers that can come with certain bypassing, by obviously bypassing the neutral safety, just putting the wire from the start side of the ignition switch directly to the S terminal, this machine will start in gear, and that could be potentially dangerous and even deadly. So if you're going to bypass, something with the starting circuit, there should be a neutral, at minimum, a neutral safety device implemented. Whether you're going through the switch or whether you're making your own neutral safety circuit. And even with that, even if they did that, you would still have the same issue with the power relay with the specific fuel system, where it would time out. That if you just didn't try to start it on the first go, the engine wouldn't start. So, that's the issue with, trying to, do some bypass repairs, especially if you really don't know how the circuit is supposed to work, and it could potentially be dangerous. But this is fixed the way it's supposed to be. Just to show you, I'm now in forward. Gonna start it. Obviously it won't start because I'm not in neutral. Put it back in neutral. All right, thanks for watching. And this is just a little test after the fact, just to confirm that start request is on the load side of the starter relay, not the control side. Because once you key on, the negative is supplied by the ECM for the starter relay. And that the start request is actually when the relays engage and the load side contacts of the relay close. So what I'm going to do is, right now I got the key off. I'm going to cycle it on, and the power relay is going to cycle off. Right, and all I'm going to do is jump the load side contact of the starter. And once I put voltage on this circuit, the starter is going to run, and the start request circuit will see 12 volts, and the power will come back, and the engine will start. So here we go. All right. That's just a little confirmation, because I didn't have the exact wiring diagram for this application.